Imagine you are driving, let's say 70 miles an hour down a really busy multi-lane highway.
Okay. Setting a stressful scene right off the bat.
Right. And you go to press the brake pedal, and it just drops. I mean, straight to the floor.
Oh, wow. Yeah, terrifying.
No resistance, no deceleration, just pure panic.
Yeah.
Now ask yourself, for this exact moment, would you rather have prepared by, sitting in a quiet conference room, reading a bullet-pointed PowerPoint about hydraulic fluid failure?
Definitely not.
Exactly. Or would you rather have practiced this exact crisis 10 times in a hyper-realistic simulator, like physically feeling the steering wheel fight you while you learn to downshift and use the emergency brake?
Yeah, I mean, the answer for anyone tuning in today is probably obvious.
It's completely obvious.
Yeah.
But the crazy thing is, in some of the most dangerous high-stakes industries on the planet, that PowerPoint presentation has literally been the standard for decades.
It is honestly a staggering reality to confront.
But that changes today. Welcome to today's deep dive. We're unpacking a press release issued today, July 14, 2026, by a company called EON AI Ventures.
Right, and they're announcing a new platform. It's called the Situation Room.
Which is such a cool name, honestly.
It really is. And to use your analogy, this is fundamentally a flight simulator, but for industrial plants.
Our mission for you today is to really unpack how this technology replaces those decades of passive, check-the-box safety training. Because this isn't just generic corporate safety.
No, not at all. It is a piece of technology built to digitally recreate the exact high-stakes moments that have historically cost millions of dollars and, tragically, human lives.
And it uses immersive, physics-driven survival scenarios. But to really grasp the magnitude of what they're releasing, we have to look at the bloody legacy of the status quo.
We do, because the source material grounds this entire project in history. The Situation Room is built around this curated catalog of 120 industrial situations.
And those are spread out across 7 genres plus a flagship set.
Right. Exactly. And those genres are incredibly specific. They're targeting the most notoriously dangerous moments in industrial operations.
Right. The press release mentions things like lockout and stored energy events, startup and shutdown transients, overpressure and relief.
Rotating equipment failures, process upsets, loss of containment. It's an intense list.
Let's actually pause there and translate a couple of those terms.
Okay.
Because they sound, very technical. But the reality of them is incredibly visceral.
Oh, absolutely.
Like when the text says lockout and stored energy, we are talking about the protocol where a worker physically padlocks the power switch of a massive piece of machinery.
Right, so it cannot turn on while someone is inside repairing it.
Which is terrifying. Because if that goes wrong, the machine wakes up with a human inside.
Yeah, it's a life or death protocol.
And what about startup and shutdown transients? What exactly is a transient?
So think of a transient as the highly volatile window of time when you are waking a complex system up or putting it to sleep.
Like turning on a car in the cold.
Sort of, but a massive chemical distillation tower isn't like a light switch. You don't just flick it to on.
Right.
There is this unstable period where pressures are building, fluids are heating up, and the system is trying to find its equilibrium.
And let me guess, that's when things usually go wrong.
Statistically, yes. This unstable period is where a massive percentage of catastrophic incidents occur.
Wow. And these 120 situations in the software aren't just hypothetical worst-case scenarios dreamed up by some programmer in Silicon Valley, right?
No, every single one is based on real, documented incidents.
The press release points to some of the darkest days in industrial history. I mean, it mentions the Piper Alpha oil rig disaster in 1988, where 167 people lost their lives.
It also brings up Buncefield in 2005 and the DuPont-LaPorte incident in 2014.
But the one that really stood out in the text is the BP Texas City disaster in 2005, which left 15 dead and over 180 injured.
Yeah, BP Texas City is a foundational example of why this technology was built in the first place.
Awesome.
Well, following that disaster and others like it, you had these massive multi-year forensic investigations. Agencies like the CSB, the Chemical Safety Board, and OSHA poured over the wreckage.
Right, they document everything.
Exactly. Industry groups created these incredibly detailed, brilliant records of exactly what went wrong down to the actual second.
But here is the part that genuinely stops you in your tracks. We have all this forensic science. We know the exact sequence of events that led to a chemical tower overflowing and igniting at Texas City.
We know exactly how it happened.
And yet, the founder and chairman of EON AI Ventures, Dan Lajerskar, has a quote in this press release that is just a brutal indictment of how we've used that data.
Oh, it's a fantastic quote.
He says, the industry has spent 50 years writing brilliant incident reports and then training people with slide decks.
It is a devastating observation.
Yeah.
Because it highlights this massive psychological gap.
Right, wait, so up until now, all that forensic science from OSHA and the CSB was just being bullet pointed in a boardroom.
Pretty much. And think about how a human brain processes a slide deck. When you read an incident report about BP Texas City in a calm, temperature-controlled room with a cup of coffee...
You're completely relaxed.
Exactly. You are absorbing intellectual knowledge. You are logical. You are rational.
But when an industrial plant is actually failing around you, when the warning sirens are screaming, when valves are rattling, and your radio is blaring with conflicting reports, you are no longer in an intellectual environment.
You are in a situational, adrenaline-fueled crisis.
Your prefrontal cortex basically shuts down and you drop into pure survival mode.
Precisely. And intellectual knowledge simply does not reliably translate into situational reaction when that adrenaline hits.
That makes total sense.
A PowerPoint can tell an operator the sequence of events that led to an explosion in 2005. It cannot train their nervous system to recognize the subtle, real-time signs of that sequence happening again.
And interrupt it before it's too late.
Exactly. That gap between historical knowledge and real-time execution is where the fatalities happen.
So if a PowerPoint fundamentally fails to train a human nervous system for a crisis, what actually can?
Well, that leads us directly into the technological solution EON AI Ventures built.
Right, the live physics engine. The overarching platform here is called EON Live. And right away, the source makes it clear this is not just a generic video game where you use a joystick to walk a cartoon avatar around a fake factory.
Far from it. The underlying architecture relies on this facility understanding layer they call EON Universal.
EON Universal. Okay, what does that actually do?
This is where the enterprise application gets really sophisticated. Instead of a one-size-fits-all training module, it automatically scans a specific customer's actual facility components and topology.
Oh, so it ingests the data of what that specific plant looks like.
Yes.
Let's dig into that for a second because the text gives a highly specific example. It says that a training scenario requiring a distillation column and a blocked bottoms valve will only light up as a playable option on a rig that actually possesses those specific components.
Which is brilliant.
And just to clarify for everyone listening, a blocked bottoms valve essentially means the exit pipe at the bottom of a pressurized tank is shut, but fluid is still pouring in from the top.
All right, it's basically a pressure cooker with no release.
And if your plant doesn't have that specific setup, the system won't waste your time training you on it.
And the implications for enterprise customers are huge. First, from a psychological standpoint, it eliminates the classic worker excuse.
Oh, I know this excuse. This doesn't apply to my plant.
Exactly. If an operator sits down and says, well, this generic training doesn't look anything like my specific plant, so I'm going to tune out, they lose that out entirely.
Because the simulation is taking place on a digital twin of the actual pipes and valves they touch every single day. They're quite literally practicing in their own workplace.
Yes. And secondly, there's the financial angle. The president of EON AI Ventures, Mats Johansson, makes a point of saying that customers do not need another scenario built site by site at consulting prices.
Ah, right. Historically, if a chemical company wanted a customized simulator, they had to hire a consulting firm to write thousands of lines of bespoke code from scratch.
For every single facility. It was incredibly expensive. EON Universal automates that matching process.
So it's a compounding library. You load the plant data in, and the system cross-references those 120 historical disasters, figures out which ones are physically possible at your plant, and builds the scenarios automatically.
That's the idea.
But the part that I found genuinely fascinating is what happens once the scenario starts running.
Oh, the physics engine.
Yes. The consequences in the simulation don't happen because a programmer wrote a script saying, okay, at minute 3, trigger the explosion animation.
Right, it's not pre-rendered.
The consequences emerge organically from a real-time physics twin. And the internal mantra at the company for this is, physics doesn't hallucinate.
It is a very deliberate choice of words, especially in the current technological climate.
I love that phrase. It feels like a direct, heavy-handed jab at generative AI, right?
Oh, it absolutely is.
Yeah, because think about it. If I ask a large language model chatbot, what happens when a pressure valve blows on an oil rig? The AI is just guessing the next most likely word based on text patterns it read on the internet.
It might give you a plausible sounding answer, or it might completely make something up.
It hallucinates.
Hmm?
But if I ask a physics engine, it isn't predicting text. It is calculating the literal mathematical fluid dynamics. It's the difference between a storyteller and a mathematician,
Right,
right?
that is the exact distinction they are emphasizing. The EON AI engine is constantly computing what they call Tier 1 real-time physics.
Tier 1 physics.
Yeah, every millisecond, the software is calculating the pressures, the temperatures, the fluid levels, and the valve states.
So the situation plays out entirely based on those mathematical realities.
Right. If the operator opens a relief valve in the simulation, the pressure drops, not because a script says it should, but because the simulated math demands it.
But the press release is also incredibly transparent about where the physics computation stops, which I appreciated. They draw a very hard boundary.
Yes, they do.
They note that consequences beyond that Tier 1 physics layer, like the actual blast overpressure of an explosion or the structural collapse of a building, those are presented as preset consequence states.
And that boundary is crucial for maintaining engineering integrity.
Because computing an explosion is too complex.
Exactly. Computing the exact chaos of a massive explosion, how every piece of shrapnel flies, how the shock wave interacts with every single steel beam that requires supercomputer-level processing.
Which you obviously can't run efficiently on a commercial training platform.
Right. So by explicitly capping the real-time computation at the Tier 1 pressures and temperatures, they avoid misrepresenting those massive chaotic events as precise computed physics.
It really proves they are treating this as a serious engineering tool. It
Yeah.
isn't trying to be a Hollywood blockbuster. It is trying to keep people alive,
Absolutely.
which naturally makes you wonder,
Mm-hmm.
what is it actually like for an operator to log into this system? How do you interact with this terrifying physics engine?
So the user interface is called the mission library, and workers browse it kind of like a catalog.
Each historical situation is presented as a card.
Right. And the structure of these cards represents a major shift toward radical transparency in the safety market.
How so?
Well, before diving into a simulation, the worker reads the card. It breaks down exactly what happens in the scenario, why it matters, how to handle it, how often it occurs in the real world, and what the historical consequences have been.
I want to highlight the how often metric, because this blew my mind. The press release notes that 66 of the 120 titles carry real, publicly cited frequency statistics.
Meaning they can point to data proving exactly how often this failure happens globally.
Right. But for the remaining 54 situations, they don't have public data. And instead of doing what so many tech companies would do, which is invent a proprietary statistical model to guess the frequency and make the software look smarter, EON N simply marks them as not quantified in public sources.
It is a remarkable level of candor.
It really is.
In a corporate training market that is highly saturated with generalized, unsourced content, admitting what you do not know builds immense trust with engineers.
Yeah, if the data is real and verifiable, they present it. If it doesn't exist, they refuse to dress it up with fake numbers.
Exactly. But the real ingenuity of the mission library isn't just in the transparency of the data, it is in how the platform scales the difficulty of the experience.
Okay, let's get into the difficulty levels, because this is where the system gets truly diabolical.
It really does.
The text outlines 3 levels for every single title in the library: beginner, operator, and expert. But I want to make sure I'm reading the source material correctly here. Changing the difficulty from beginner to expert doesn't load a totally different scenario, right?
No, it is the exact same underlying scenario.
So to be clear, it just twists the physics dials in the exact same scenario until things go completely off the rails.
Essentially, yes. The text is very clear. The difficulty is not new content. When a worker boots up a scenario in beginner mode, the system provides helpful guiding prompts.
Kind of holding your hand.
Right, and more importantly, all of the virtual sensors and gauges in the simulation are perfectly honest. If the tank is full, the gauge says it is full.
Okay, makes sense.
But when you escalate to expert mode, the system runs the exact same historical situation, but it strips away the guidance, it introduces cascading faults, it tightens the time margins, and crucially, it introduces at least one lying sensor.
A lying sensor.
Yeah.
That is just rude.
Uh-huh.
You are operating a highly explosive chemical plant, and the instruments you rely on to tell you what is happening are actively lying to you.
It sounds totally unfair, but it is the terrifying reality of industrial disasters. This brings us right back to the BP Texas City disaster we discussed earlier.
Right.
A primary catalyst for that massive explosion in 2005 was a misleading level gauge.
Wait, really? The disaster that killed 15 people started because a gauge lied.
Yes. The operators were filling a massive distillation tower. The instrument panel in the control room indicated that the liquid level in the tower was slowly dropping.
Which told them they had plenty of space to keep pumping fluid in.
Exactly. But the instrument was stuck. The tower was actually filling up.
Oh my God.
They trusted the lying sensor, the tower overfilled, the highly flammable liquid geysered out of a vent stack, and it found an ignition source.
It's chilling.
And it perfectly illustrates the philosophy behind Dan Lajerskar's quote. A slide deck can tell a new hire what happened to Texas City, but the Situation Room puts that new hire in front of the exact same misleading level gauge, lets the real-time physics run, and forces them to notice the subtle discrepancies.
Training workers to actively distrust their own instruments, to cross-reference a temperature gauge against a pressure valve, to look for secondary confirmation that is a complete paradigm shift.
Because in the real world, failures don't announce themselves politely.
Right. The text explicitly points out that these incidents cluster around startup transients and isolation errors. Those are highly volatile, confusing moments where the data is already noisy.
And conventional safety videos almost never rehearse the specific cognitive dissonance of realizing your dashboard is lying to you.
But because EON on Live is driven by a live physics engine rather than a static script, it generates the run freshly every single time. The lying sensor might be the pressure gauge on Monday and the temperature readout on Tuesday.
One simulation yields effectively infinite variations of the worst moments in industrial history.
Which leaves us with the final critical question for the enterprise. If a worker is battling these infinite physics-driven variations, how does the company actually measure if they are learning anything?
Thankfully, it is the absolute end of the multiple choice quiz.
Oh, thank goodness. We've all taken those corporate training quizzes where the answers are painfully obvious and you just click through to get your certificate.
Right. The platform completely abandons that model. The assessment logic is tied directly into the physics engine.
So workers are not given a percentage score in a quiz at the end.
No. Instead, their competence is scored based purely on their physical actions within the simulation. Did they physically stabilize the situation?
Did they successfully isolate the blocked valve?
Exactly. Did they bleed the pressure in time? Did they catch the lying sensor before the system reached a catastrophic point of no return? The platform checks their actions against a specific rubric for that card.
You know, this is exactly like the difference between passing the written permit test for your driver's license versus actually proving you know how to steer out of a hydroplane on a wet highway.
That's a great way to put it.
Passing a written test just proves you could read the handbook. Recovering from a hydroplane proves you can actually survive the crisis.
That is the essence of what EON AI Ventures calls provable competence. For decades, high-risk industries have relied on a model of compliance.
Right. A worker attends a 3-hour safety seminar, they sign a piece of paper, and the company checks a box to limit their liability.
The worker is compliant, but are they capable? This technology shifts the focus from legal compliance to genuine provable capability.
It provides a digital record proving that an operator can actually stop a meltdown on their specific daily equipment.
And this ties into the massive overarching vision mentioned at the very end of the press release. EON AI Ventures isn't just trying to sell a training tool.
Right, they are trying to build a platform for what they call work intelligence, or WI.
They describe this as the enterprise's missing system of record. It captures the data of how work is actually done in these crises.
And turns that human performance into an owned, compounding digital asset for the company.
And we cannot understate the scale at which they were attempting this.
Yeah, let's talk about the scale.
The source material notes that EON AI Ventures supports over 4,400 institutional customers spread across more than 80 countries.
That is massive.
They are building this on 25 years of experience in immersive learning. When a platform operating at that massive global scale decides that the era of passive slide deck safety training is fundamentally over, the entire industrial landscape is going to feel the shockwave.
So to wrap this up for you tuning in, what we've unpacked today is how the Situation Room is taking the tragic, hard-won lessons of history, the heavily investigated disasters like Piper Alpha and Texas City, and finally rescuing them from the boardroom PowerPoint.
It really is a rescue mission for that data.
By utilizing EON Universal to ingest a real facility's layout and a live physics engine to run the Tier 1 consequences, they are ensuring that operators can practice the most dangerous, complex moments of their careers safely, repeatedly, and with provable competence.
It is a profound example of technology serving as the bridge between historical tragedy and future human performance.
Because it takes the forensic knowledge of what went wrong in the past, and instead of just filing it in a report, It turns it into a behavioral, adrenaline-tested reflex for the future.
Exactly.
And even if you don't work on an oil rig or in a chemical plant, the core philosophy behind this technology matters to you.
It really does.
We all live in a world where we increasingly rely on digital dashboards, screens, and automated alerts to tell us what is happening around us. We trust the data blindly.
Often without a second thought.
EON Live's expert mode forces workers to survive a lying sensor. And it makes you wonder, in your own life, your own work, or your own car, how quickly would you spot the disaster if the digital dages you trust every single day suddenly started lying to you?